different types of operations going on, you need to think about which bounds you're going to use. So the rectangle question was really straightforward, because to find the upper bound of the area, you just multiply the two biggest numbers together, upper bound times the upper bound. To find the lower bound of the area, you do lower bound times lower bound. Now, it doesn't just apply for areas, any two things that you're multiplying to find the biggest or smallest answer. Now, the same thing applies when you're adding, obviously. So you want to add the two smallest numbers together, and you add the two smallest numbers, the two biggest numbers for the upper bound. When you are subtracting, though, this is a bit more different, and you have to think about how you would approach these type of questions. So if you have y minus z, those are your two constants that have been rounded to some degree of accuracy. To find the smallest possible answer, you're going to want y to be as small as possible and z to be as big as possible. That will leave your answer as small as possible. So the lower bound of y, take away the upper bound of z. And then conversely, when you're finding the biggest potential answer, you want the upper bound of z, upper bound of y, take away the lower bound of z. Now, when you are doing division, you need to think again carefully at this. A nice way to think about this is just to think of the numbers 5 and 10, for example. If you have a small number divided by a big number, you get, in this case, a half. If you swap those around, you get 10 over 5, which is 2. So if you're looking for the lower bound, you want a smaller answer, well, then you want the top number to be as small as possible and the denominator to be as big as possible. So the lower bound is the lower bound of y divided by the upper bound of z. I have highlighted the subscript lower in both cases because that's how I remember it. I just remember the lower bound goes on top, and to find the upper bound, you put the upper bound on top and divide by the lower bound. Otherwise, you just have to think about it this way. Do not try to memorize and just think about the logic behind this. Now, sometimes you'll get formulas with square roots and surds and powers. You keep them in there when you use them, but it doesn't affect the bounds in terms of you don't have to do anything special to the bounds. So if, for example, you're told there's a formula to work something out, which is 1 over root z, and z has been rounded to some degree of accuracy, well, to find the lowest potential, that lower bound of x, you do 1 divided by the upper bound of z, and you square root that value. And to find the upper bound, you do 1 divided by the lower bound of z square rooted. And then the formula on the right, again, it looks a little bit tricky, but it's just a 4 times a square root of something, y over z. The 4 just stays as a 4 unless you're told it's been rounded. So let's just assume that's a constant. For example, in a formula, half times base times height, you would just leave the half, and then you'd figure out the base and the height according to the bounds that might be given to you. And then in this case, the lower bound is following the same logic as the previous slide. So lower bound of y square rooted over the lower bound of z, the upper bound of z square rooted. And just as a rule of surds, technically you can do lower bound of y divided by upper bound of z and then square root the whole thing in one go. But that's just another way to do it, get the same answer. And then the same for the upper bound, you do upper bound divided by lower bound times 4. So this is the summary slide. Don't memorize it, just think about it logically. I have put this as a PDF on Google Classroom, so you can print it off or you can copy it down. If you want to pause the video and copy now, you're welcome to do that. It's up to you. Otherwise, you have a reference and you can actually work these all out yourself. Okay, so here's a practical example just to go through. So a sewage tank has a volume of 1,500 litres correct to 2 significant figures. Mike empties the tank using a large bucket, which is 20 litres to the nearest litre. What's the smallest number of times he must fill his bucket? And what's the greatest number of times in theory? So we're looking at 2 scenarios where in one scenario, the bucket is as big as possible and the tank is as small as possible. So that's the smallest number of times that he could fill it in. The greatest number of times would happen if the bucket was small and the tank was big. So we can say the number of times that he needs to fill up, that he needs to transfer this sewage is the volume of the tank divided by the volume of the bucket. You can then write out your bounds. Now, two significant figures for 1,500. Well, that 5 is the second significant figure. The place value is 100. So you half 100 to get 50. So the upper bound and lower bound, we're adding and subtracting 50. That's for the tank. So 1450 and 1550. And then for the bucket, this is to the nearest liter, so we add and subtract half a liter, so 20.5 and 19.5. So the number of times, if you want to find the lower bound, just if you remember from the previous slide and from your summary sheet, we're going to divide the lower bound of the volume by the upper bound, so the lower bound of the volume of the tank by the upper bound of the volume of the bucket, and then vice versa for the upper bound. And you can see it's anywhere between 71 and 80 times that he will have to transfer that stuff. This is meant to be an in-class activity where you might use mini whiteboards. I think it's worth doing just to test what you know. So I'm now going to show you all of the questions which are on the left-hand side, and then you're going to, in your book, just write something like that. So lower bound of B times the upper bound of C, and so on. So here are the calculations that you need to work out. And be careful to read the middle column as well. Sometimes it's lower, sometimes it's upper bound. So here are your calculations. Pause the video, have a go at this. When I check your work, I'm going to be looking to see how many you got. It's fine if you get them wrong and correct them. I would expect to see corrections. So, okay, so here are the answers. Okay, so let me know how you've done. Upload a picture of that onto Google Classroom when you submit all of your work. Now, here's a question for you to practice. Okay, I'm going to go through the answers here. So you should have, we know that the area is the base times the width. That hasn't been given to us, but we know that. You're going to need to rearrange this into width equals area over base because we don't know what the width is. We're going to work out the bounds. So to work out the lower bound, I'm going to do the lower bound divided by the upper bound. Now for 80, if it's to one significant figure, well, that 8 is the first significant figure. Half of 10 is 5, so 85, and so that should be plus or minus 5. So you have 85 and 75, and then for the second value, you got 12 to two significant figures, so we're going to add and subtract half each time. Now, the lower bound for the width, well, the area, the lower bound for area is going to be 75, and the upper bound for the base is going to be 12.5. So you divide those two by each other, and you get 6 centimeters is the lower bound for the width. Okay, so the next video is going to have just 1 or 2 examples, and then you're going to do the final worksheet for this. See you next time.